Okay, good morning. My name is Paul Murphy, and as Camille said, I work for SDS International, which is based at MIRAS at the University of Manchester. And I'm going to talk about how aggregate socio-economic data can be and is being made more accessible to local researchers and citizens in developing countries. And I'll start by talking about what the barriers of access to data are, and we'll look at how these barriers to data are being broken down by data being made more open, and some tools that facilitate the sharing of data and knowledge, and advances that have been made in the technologies that power data collection and dissemination, such as the Statistical Data and Metadata Exchange Initiative and application programming interfaces. And we'll end by looking at the development of the semantic web and how linked data is behind it. Wealth of data on development exists, notably in the datasets of the UN and World Bank, which are especially focused on the developing world. But if you're in the developing world, getting access to this data is difficult. There are two main reasons for that. Firstly, there's the cost of the data. Publishers are traditionally charged for access. As an example, a single copy of a World Bank dataset would have cost around $50 for someone living in the developing world. And secondly, there are technical barriers. The data was often sent on CD or in a text file, but there were no standards, and each publisher would use the format that was most convenient for them. Metadata, if it even existed, was usually an afterthought, perhaps in an accompanying manual, but often not with the data itself. And metadata is very important. It's difficult to understand and correctly interpret the data without the metadata. With no standards, there was no way for developers to build applications on top of the data, and of course infrastructure, lack of access to computers, the internet, and even something as basic as a stable electricity supply. Now, with the exception of infrastructure, all of these were problems not just for the developing world, they were a problem everywhere. In the UK, this was recognised by academics, and the UK's Economic and Social Research Council funded MIRAS to create SDS International, a national data service that would provide UK academics with access to high quality country and regional level socio-economic data, and this is led by Dr. Celia Rusty. MIRAS negotiated data licenses that covered the entire UK academic sector, and that made that made data free at the point of use, which got rid of the cost barrier. And the data was delivered via a single web interface, so there were fewer technical barriers. And it's been a huge success. Since 2003, we've had over 25,000 people use the service, and last year there were over 120,000 downloads of data. The SDS International now hosts 37 different data sets from the IMF, the OECD, UN, and World Bank, amongst others. And here's what Siobhan Carey, the former head of statistics at the UK's Department for International Development, said about the service. Every policy department looks beyond national boundaries. The SDS International is essential for the development of a cohort of researchers with the skills to undertake comparative analyses. So there really is a demand for this type of data, but because of the licensing conditions imposed by the data providers, this service has only been available to UK academics. Over the past few years, political and technical advances have begun to change the data world. In 2007, the UN made their common database freely available. And this was a major data set. It had over 300 statistical series on human development for over 280 countries and regions. The statistics were from across many of the UN's different agencies. It's now called the Key Global Indicators, and it's part of the UN's data portal, which includes other freely available data, notably the Millennium Development Goal indicators. In July this year, the World Bank followed suit and opened access to their data. The World Bank is really one of the most authoritative sources for development data. They publish 3 data sets that between them contain over 2,000 indicators with data going back as far as 1960. So it's a very rich source, and it's all to do with development. And the reason they've done this, as well as to reach new audiences, is to encourage others to open and share their data and to foster innovation. And an important thing they've done is to create an API to allow applications to be built on top of the data. I'll come back and talk about APIs a little later on. Of course, these aren't the only sources of freely available data, and SDS International maintains a list of others on its website. So far, I've concentrated on large time series data sets produced by intergovernmental organisations, but there are many other sources of data collected by local organisations, researchers and ordinary citizens, and there needs to be an open and accessible way of sharing these as well. To that end, the OECD have created two wikis, WikiProgress and WikiGender, and many of you will be familiar with Wikipedia. It's a collaborative tool that anyone can contribute to and anyone can edit. And these wikis are the same principle, but unlike Wikipedia, users can contribute their own original research. And users can also contribute entire data sets, and they go into a database called wikiprogress.stat. This is an example of a data set that's been deposited in wikiprogress.stat. It's the Is Life Getting Better data set created by the Global Social Change Research Project. And I know who created it because it's all in the metadata that you can see there at the side. This particular data set draws together data from several US and UN departments and from the MDG poverty indicators to look at improvements in the quality of life. WikiProgress was launched late last year, and it's part of the OECD Global Project, which is an initiative that aims to find better measures for the progress of societies. It's not aimed exclusively at the developing world, but much of the information that's in there is relevant. WikiGender was the other one that I mentioned, and that's the same, but its focuses on gender equality related issues. Okay, so I've talked about how open data and sharing of data can overcome the cost barrier, and now I'd like to talk about these technical barriers. Exchanging time series socio-economic data sets can be difficult. They're often very large and have very varied and complex structures, and different practices between the data providers have made it even more complex. The major data providers, including the UN, the World Bank and IMF, realised that this was a problem, and to address it they formed the Statistical Data and Metadata Exchange Initiative, the aim of which has been to create a set of standards and guidelines to facilitate the exchange of this type of statistical information. And SDMX is comprised of two things. It's a set of content-oriented guidelines that suggest recommended practices for creating interoperable data and metadata sets, and an ISO technical standard for the transmission of data. There are many benefits to standardising the exchange of data. Firstly and most importantly, it's better for end users. Using SDMX, developers can build much more user-friendly interfaces that make the data easier to understand and easy to use. It's much more efficient, it reduces the reporting burden. Because the national statistics offices that collect the source data and the aggregators of data are all working to the same standards, so less time is spent manipulating data and converting it between systems. And data sets produced in SDMX are self-descriptive. Everything you need to understand the data set is contained in a standard format. So the code lists, structures, hierarchies and metadata, it's all there and it's all in a format that machines can understand. And this makes the data more interoperable, and that allows developers to build applications that aggregate data from many different sources. An example of this is the Joint External Debt Hub. This is a site that combines data on external debt from 4 data providers: the Bank of International Settlements, the IMF, the OECD and the World Bank. And you can see the type of data here. This is a comparison of the international reserves held by China and the UK. And of course, there's a huge difference there, and that's because China is the world's largest holder of foreign currency reserves. This data is provided by the IMF, but you can see it's being shown in the Joint External Debt Hub at the World Bank. Prior to SDMX, each of the developers would send in their data, and it was manually collated, and this took 3 months for each release of the data. The Debt Hub's now been updated to use SDMX, and the processing of data is entirely automated. When one of the providers updates their data, a message is sent to a central registry. When the software powering the Debt Hub monitors this registry, so it knows that new data is available, and it then goes and retrieves it from the original provider. And once it's got that data, it can then update the website with it. And all this happens in real time, so users of the Hub are no longer using data that's 3 months out of date. The Joint External Debt Hub has been developed by the data providers. Where data is openly available and disseminated using SDMX, there's nothing to stop an enterprising developer doing the same. The UN Statistics Division has been working to implement the Millennium Development Goal indicators in SDMX, and this is the SDMX registry that they've created. So any developer can set up software to connect to this registry, and they'll be automatically notified of any updates to the MDG indicator data, and they can then go and download that. Now, I mentioned earlier about open data fostering innovation. Well, to do that, developers need access to APIs. API, for those of you not familiar, stands for Application Programming Interface, and it's essentially a way of allowing different bits of software to talk to each other. And this is an example of an application an independent developer has built using the World Bank's open data and APIs. And it's called Blind Data. It looks at the completeness of data in the World Development Indicators and Global Development Finance data sets. And by completeness, I mean it looks at whether data exists for each of the individual data points. It's broken down by topic, and if we look at poverty, which is the least complete of the topics, we can see that only 4% of the data is there. And by looking at this chart at the side, we can see that in the poverty series, almost no data on poverty existed for the first years. It's only in more recent times that poverty data has gradually become more available. And from the jagged nature of the line, we can infer that the data is not collected annually. Here's another example. Again, it's from Blind Data, but this time the developer has tied the World Bank data into another API, the Google Visualization API, which is used to generate this map. And this map shows the completeness of data by country. So darker is better. It means more data is available. So we can see the World Bank have very complete data for most South American countries. Western countries, again, relatively good. Former Soviet countries, not quite so good. And then the areas where there's been a lot of conflict around the Balkans, Afghanistan, Iraq, and Libya, there's very, comparatively very little data available. Now, one of the technical barriers to data that I mentioned was infrastructure. Something that's been done starting to address this is the making of data available on mobile devices. This image that you see here is taken from the World Bank's mobile phone application. And this application allows you to view and visualize some of their indicators. And the OECD have a similar phone application. Now, I should stress that this doesn't solve the infrastructure problem. Mobile devices in the current form are not a substitute for being able to access and analyze data on a PC. And the screenshot you see here is from a high-end mobile device that you wouldn't expect to see in a developing country. But it does demonstrate the potential and how building applications on top of data can make it more accessible. And I know we're going to hear some more on the theme of mobile technologies from some of the other speakers. Tim Berners-Lee, the creator of the World Wide Web, believes the next big innovation in the internet will be the semantic web. You may also hear this referred to as linked data. Now, typically, data on the web isn't the raw data, it's a HTML representation of it. Linked data is the raw data and it's made openly available. It's in a standard format called the Resource Description Framework, or RDF, and it's described in a machine-understandable way. And it's linked to other data. I'll explain more about linking data in a second. First, I want to show you the semantic web as it currently stands. And this is it. This is how the semantic web looks as of this month. All these circles you see here are data sets, and the arrows between them are self-describing links. You can see here that there's a lot of data here. The big central one that you can see lots of links going into, this is DBpedia, which is Wikipedia in linked data format. And this web is growing larger every month. And this is how linking of data works. You have something you want to describe. So in this example, I'm going to try and describe this workshop. And this thing has properties, one of which will be its name, so ICT and knowledge for the developing world. It also has a time. In this case, it's an event. And the event is going to be held in Shanghai. So we could have a property that said Shanghai. But Shanghai in itself is a thing. So rather than it's a city, rather than just create a property for it, we link to it. So DBpedia will have an entry for Shanghai, so we just link straight to that. And we then have access to all that data about Shanghai. So now we have our own little semantic web here, and we could start to query it. So I could send the query, what country is the event being held in? Now, I've not specified a country there, but because we link to Shanghai, and Shanghai itself, through DBpedia, would be linked to the country, like that, we can infer that the event is being held in China. This is a very small example. When you start to do this kind of linking in and inference on a much larger scale, you suddenly have a very powerful resource discovery tool. Now I've shown you two different ways of modelling data, SDMX and linked data. So you might be wondering why multiple standards and which one should socio-economic data be made available in? Well, there's a need for both. SDMX is highly structured and geared towards the collection and dissemination of aggregate statistical data, while IDF is designed more as a general purpose tool for describing lots of different types of data. Now, Myriad is an expert in dealing with both of these, and we've been working with the UK's Office for National Statistics, amongst others, to come up with a way of translating SDMX to RDF and exposing it to the semantic web. And a proposal is being put to the sponsors of the SDMX initiative to include that in the SDMX standard. So, looking to the future, what can we expect from the data world? Well, we can expect more data to be made freely available and greater use of standards. We can also expect to see data being added to the semantic web. And when that happens, resource discovery will become much easier. And when dealing with the exponential growth in data that we are, this will become ever more important. And with data being made available in a machine-understandable format, we can start to do some really amazing things. Significant advances are being made in the area of artificial intelligence, particularly biologically inspired artificial intelligence. And when applied to linked data, these processes might even be able to make the semantic web do some of the thinking for us. So that's the end of my talk. I'd just like to end by saying thank you to ASA UK China and the Chinese Academy of Sciences for funding the workshop, and to Professor Liu and Celia Russell for organising it.